So the IPCC is, the Intergovernmental Panel on Climate Change. So they're going to be very interested in emissions because that is something that it makes sense, right? Because like emissions is a global problem, and it's one of the ways where the you can't just have one country or a handful of countries just impacting and leaving their CO2 waste and impacting the nations of everyone else. So it makes sense to be at the national level, international level, to be thinking about emissions. So this is kind of their idea of what and this one specifically is basically about kind of like how do we what are some steps forward. It's a very like pragmatic one this time. So basically what you're looking at, we're looking at the many options now available, and there's a bunch of horizontal bar graphs. Science is really into now, like kind of as a field, these huge figures where it's like really, it's like a steak dinner. We're not doing like these little, gone are the days where a single bar graph meant a single thing. So it can be kind of like daunting at first, but what we're looking at here is you have the energy and the mitigation options on the left-hand side, and they're listed down. So they have energy. AFOLU is agriculture, forestry, and other land use, buildings, transport, and in those is basically ways of figuring out, industry, for example, energy efficiency, material efficiency. So improving those things, how much is that going to impact it? Well, and that's what the x-axis is. The length of the bar is the potential contribution to net emission reduction. So if you go to so for example, the top one, energy, wind energy is it's like the biggest graph, the biggest bar graph on the figure.
Yeah.
And blue is good. So blue means that it's super cheap to do this. And then as you get like darker and darker, it gets more and more expensive. So what we want is really big bars that are blue or yellow. And the big stuff is wind and solar energy. So this is kind of like why this is talked about so much. This is why it's so big, and it has to do with wind and solar. It's renewable, meaning that it just keeps going. We don't have to keep putting energy into the system in order to get some back. Obviously there has to be maintenance and that kind of stuff, but we're not talking about like, we need to burn fuel in order to get fuel. That's the kind of thing that we're talking about. So wind and solar are huge for us. And then going down, agriculture and agriculture, forestry, and other land use is the next big bump. So we got agriculture, sequestration. So carbon sequestration is like basically, there's a lot of CO2 that's emitted in just the use of agriculture and stuff like that. So it's basically capturing that CO2 and not letting it go into the environment. And then the next one would be the reduced conversion of forests and other ecosystems. So this is what we were talking about before, where the healthy environments, healthy ecosystems are actually very productive. It's not like an either or thing. You actually have really big things that could happen by just saving the ecosystems, and that in and of itself is actually going to have a big impact. The other one that's the big one to talk about is, we should talk about the big ones here. So we have the carbon sequestration, then we have the reduced conversion of forests and other ecosystems that we were talking about. That's like wetlands and stuff like that too. And then 3 is ecosystem restoration and reforestation and stuff like that. So in ecology, it's well known what makes a really healthy ecosystem. We know this is studied very well. You need a lot of species, so this is biodiversity, and then you need a lot of each species. So you need like a lot of different types of butterflies, and then each of those types of butterflies, a lot of those in those populations. And that's because you want genetic diversity. So biodiversity, a lot of different types of animals, genetic diversity, a lot of the same types. So they can kind of breed.
So they can breed and they can absorb shocks.
Exactly.
So
Exactly.
Well, I experienced this as well, like with the way I run my YouTube channel as a business, because I like having lots and lots of small patrons, because if somebody stops liking me, or their financial situation changes, or they die, as happens, it's like, do I want one patron who's giving me like 50% of my money if it's like $1,000, or do I want 50 patrons contributing to about $800? That if that happens, that gets replaced, or I'm able to adapt carefully, because it's not just like major like support is just gone. And
Yeah.
the same deal here. If you have low biodiversity, something happens to one of these organisms, that entire role is just empty.
Yeah, exactly. Yeah, it's called a genetic bottleneck, and it's a great way to go extinct, where it's like one small, you have a huge genetic bottleneck event, and you basically have one big event away from going extinct as a species. So, and that big event could be climate change. So that's not good. So then we can go down buildings. I think we could just talk about like the biggest ones.
Quick question before we continue.
Yeah,
So
yeah, go on.
I'm seeing some gray bars here. What does that mean?
That says cost not allocated due to high variability or lack of data.
Okay.
So that's reduce food loss and food waste, or shift to balanced, sustainable, healthy diets. So I think that's kind of interesting. I've seen some reports that are, especially, I'm doing a deep dive kind of like right now in fermentation and culturable meats and lab grown meats and that kind of stuff. I have a couple new videos on my YouTube channel if you're interested in that. But
I am very interested.
oh, cool. Yeah, so I think it's one of those things where I've seen conflicting data, so that makes sense that for the IPCC level, this is like,
Yeah.
I mean, there's thousands of authors on this, so there's a lot of people that are trying to contribute, getting the best data possible versus kind of like what we think. This is like what we know kind of thing. So buildings, if we go down to buildings now, so new buildings with high energy performance. So this is kind of like just better insulation. There's crazy things like situating them specific ways towards the sun for different reasons, which is kind of funny because we were kind of termite mounds in Australia that are 6 feet tall, by the way. If I've already been doing this, I don't know for how many years. That's a great question, but probably millions at this point. But we're learning from the termites on how to make a very sustainable and high performance building. And then going down to industry, then we can have fuel switching. So fuel switching, that's electric, natural gas, bioenergy, that kind of stuff. So this is kind of like what we were talking about before with like, I mean, coal. Like so much of the United States is still on coal for no reason, by the way. Even the energy costs of coal is so much worse. It's more expensive. There's no reason.
It's the conversion cost that they're avoiding by moving to something else, right?
I mean, that was actually the EPA in the United States actually had a market where you could actually have bad coal plants actually trade carbon credits with more fuel efficient stuff. And then the Supreme Court case just recently axed that. So that's makes that, yeah. Whew.
Like if it's someplace like China or India, for example, where you have like a lot of people not on like this sophisticated grid, and coal is just something that's very easy to do without like a major infrastructural development project. That makes sense. I'm perplexed when it's the most powerful technological agent in the world.
Well,
that's doing that.
It's expensive, but it's something because you have to build new infrastructure, right? That's kind of like I think why it's so expensive compared to the other options. Obviously energy efficiency would be high, but it's not as high, but it's cheaper in order to do that, which is kind of interesting. So I think that the goal, I think my takeaway from this figure is I loved it. It's really, really good way of like showcasing the different ways that we can impact the global the globosphere, and also direct impacts of things and policies and how we can change